tells you you need to sum everything up. Now it's harder to direct imagine what's going on there, but if you multiply by this component, 1 minus alpha multiplied by the top term, what you would get is the 1 multiply everything, it will be the same, right? Alpha plus alpha squared plus alpha 3. Then 1 minus alpha multiplied by this will be minus alpha squared, we can write it here. Then this multiplied by this term, minus alpha 3 until minus m plus 1, right? So if you add those two terms, basically cancels each other out, and what you left is basically alpha m plus 1. And when n is close to infinity, m plus 1 basically equals to n. So that's how you get this particular term. Same for other term. If k equals to 1, m minus 1, k alpha k would be just 1 minus alpha squared, alpha minus 1 alpha, n. Okay? Good, the internet is good. So now we just need to apply those terms into there. So we would get 2nl squared plus alpha k would be equals to alpha minus alpha n So when n close to infinity, so this first term will be much larger than the second term. We basically can eliminate it because this doesn't involve any linear term in n. This n will make this close to infinity. So we basically say we don't need to consider this component. We're going to eliminate it here. And what left is 2nl squared alpha minus n, 1 minus alpha, right? And when alpha is between 0 and 1, if you multiply this by itself 10 times, it will be close to 0. So alpha n is close to 0 as well. What you're going to have is basically 2nl squared alpha, 1 minus alpha. This is a non-self term. Now let's combine with the self term. What we have for the self term is basically h squared will be equals to nl squared plus non-self term. We just got it, 2nl squared alpha 1 minus alpha, which will be nl squared 1 plus 2 alpha 1 minus alpha. So if you do the math for this part, this will be exactly 1 minus 1 plus alpha, and the alpha is cosine theta. So that's how we get the second term. However, not every time you can always eliminate this term, and this will make a difference in the one-line chain model. So I will discuss the one-line chain in another occasion.